Welcome to this video from Derby Physics Tuition, and this is an A-level physics video looking at the conservation of energy and momentum. And this is quite a tricky question. We're going to look at the places where students can go wrong and obviously look at the correct way of solving it. So let's have a look at the question. You've got the speed of a pellet can be measured by firing it into a wooden block suspended as shown in the diagram below. The wooden block can swing freely at the end of a piece of string, and the pellet has a mass of 9.20 grams. It strikes a stationary wooden block and becomes completely embedded in it, and the centre of mass rises by 0.85 meters, and you're also told the block has a mass of 475 grams. So calculate the speed of the pellet when it strikes. So calculate the speed of the pellet when it strikes a wooden block. So we've got some information there about the mass of the pellet and the block and the height that the block rises to, which is 0.85 meters. So what we can do is we can calculate the potential energy transferred to the block. So the potential energy of the block plus the pellet, okay, because the pellet embeds itself in the block, is given by the mass of the block plus the pellet times gravitational field strength times the change in height. So if we calculate that, the mass of the block and the pellet added together is 0.4842 kilograms, changing that from grams to kilograms, and gravitational field strength is 9.81, and the height that the block is raised to is 0.85. So if we calculate that, we get 4.04 joules. So we've got the gravitational potential energy of the block and the pellet. Now the mistake that students tend to do here is that they tend to equate that to the kinetic energy of the pellet, but it actually equals the kinetic energy of the block and the pellet as they start to rise. So the pellet enters the block and they start to rise, the block and the pellet start to rise, and so that potential energy is equal to the kinetic energy of the block and the pellet. So let's calculate that. The kinetic energy of the block and the pellet is equal to 4.04 joules. So that kinetic energy of the block and the pellet is transferred to the gravitational potential energy of the block and the pellet, and we can say that that kinetic energy is equal to half times the mass of the block and the pellet times the speed squared of the block and the pellet. Okay, so the mass of the block and the pellet is 0.4842, and we're trying to find the speed of the block and the pellet. So if we rearrange that, two times 0.4842 so if we rearrange that, the speed of the block and the pellet is given by 2 times 4.04 divided by 0.4842. Okay, and that speed is 4.09 meters per second, which is the speed of the block and the pellet. Okay, now to find the actual speed of the pellet just as it strikes a block, which is what we're actually trying to do in this question, we know that momentum is conserved during this collision. So this is an inelastic collision. Kinetic energy is not conserved, but momentum is conserved. So we can use the conservation of momentum, and we can say that the mass of the pellet times the velocity of the pellet is equal to the mass of the pellet plus the block times the velocity of the pellet plus the block. Okay, so we know that the mass of the block is 9.2 grams, 9.2 times 10 to minus 3 times the velocity of the pellet just before it strikes the block, the mass of the block and the pellet is 0.4842, and the velocity of the block and the pellet, which we've just worked out, is 4.09 meters per second. So just rearranging okay, and if we calculate that, that gives us an answer of 215 meters per second. Okay, so it's quite perhaps useful. This is a 4-mark question. Quite useful to see where the marks were awarded here. So 1 mark for calculating the gravitational potential energy gained by the block and the pellet. Okay, the 2nd mark is for the kinetic energy of the block and the pellet. Okay, the 3rd mark is for using conservation of momentum, and the 4th mark is for calculating the final answer. So quite a lot of work to do there, quite a lot of physics involved, and quite a challenging question as well to think about. And as I say, the main area where students make mistakes is they equated that potential energy of the block and the pellet equal to the kinetic energy of the pellet, but you've got to go through the stages and use conservation of momentum to actually calculate your final answer, which is 215 meters per second. So if you've got any questions about this or any comments, please leave it in the comment section below, and thank you very much.